You're allowed to distribute that square root. The square root of 9 is 3 and the square root of 16 is 4. Here's another example of that, just like this. So you can just keep it as the square root of 3 over 9. You can apply that square root to the entire fraction. Now this fraction in here can be reduced. We can distribute our radicals. Simplify this. 49 times 16 equals 784. You can distribute that radical. The square root of 49 is 7. The square root of 16 is 4. 7 times 4, 28. We can distribute that square root to the entire phrase. So it's the square root of 8 times 8. 8 times 8 is 64. The square root of 64 is 8. Whenever you see a number times itself underneath the radical, we call those perfect squares. Cool? How do you reduce the square root of 72? You need to find the factor tree of it. 36 times 2 equals 72. 2 is a prime number, so we stop. Let's break down 36. Break down 18, break down 6. Now we have all prime numbers. The square root of 72 is the same thing as saying the square root of 2 times 2 times 3 times 3 times 2, because all of these multiplied together is 72. We have a perfect square right here and a perfect square right there. The square root of 2 times 2 will equal 2. This will equal 3. And we'll just leave this guy on his own over there. We do our multiplication of the 2 and 3. 6 times rad 2. So our answer is 6 rad 2. Simplify radical 88. Let's build a factor tree for that. Prime, 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 prime. So we can stop. 2 times 2 times 2 times 11. The square root of a perfect square is just that number itself. And we do our multiplication in here to get rad 22. That's our answer. Can you add these together? 1 rad 6 plus 2 rad 6s equals 3 rad 6. 5 rad 3s minus 2 rad 3s, that equals 3 rad 3s. 4 rad 3 plus a rad 7 plus 2 rad 3s, that's our answer. Can't be simplified anymore without using a calculator.